Okay, so we talked about the addition and subtraction with our algebraic numbers. Let's move on then to the next step of multiplication with them. We talked about something like this. What's that going to become? X to the 10. Perfect. We essentially just add the powers to combine them. So if we have something like this, we've kind of been over this a little bit before. We combine the counts. 6 times 12 is 72, right? But when we multiply, we also combine the names. So x times x is x squared. Good. But it doesn't have to be just x and x. Now that we know this, we can have 5x to the third times 2x to the fifth. So we're going to combine the counts. 5 times 2 is 10. Then also combine the names. X to the third times x to the fifth is x to the eighth. Good. We add the powers when we multiply. We don't necessarily have to have just one variable. We have something like this. We're going to combine the counts. 5 times 7, 35. When we combine the names, we have xy squared and x to the third, y to the fifth. I gotta learn to use smaller numbers. So anyway, when we're multiplying that out, because multiplication is commutative and associative, I can change the order around. I can move these x's up front and have x like that. And I can move these y's to the back so all the y's are together. So basically, what I can do is combine each name or each variable separately. What is x times x to the third? X to the fourth. Where'd the 4 come from? Yeah, when we see just an x like this, really there's a power there, we just don't write it. It's x to the power of 1. So 1 plus 3 makes 4. And then y to the 7th. Good. 2 plus 5 makes 7. How about this one? What's our count going to be in our answer? 19. Where does that come from? Okay. Well, remember we said that this is really a power of 1, right? Well, it's also being multiplied by something. By 1. If you think of measurement, if we have just 1 inch, we usually just say an inch, right? We don't say 1 inch. It's just an inch. Same here. 1x, a lot of times we just say x. But even though we just say x, there is really that implied 1 in front of it. So 1 times 19 is 19. And then x to the fourth, because x to the first and x to the third, 1 plus 3 is 4. What if we have something like this? Combining the counts, what do we get? Negative 35. Negative 7 times 5 is negative 35. And combining the names is x to the 8th. X to the third and x to the fifth is x to the 8th. How about this one? First of all, can I combine the 7 and the negative 5? Yes, I can. We're multiplying. We do not have to have the same name. So we got 7 times negative 5 is negative 35. Times 3, negative 105. Times negative 4, well, negative times the negative is a positive 420. Now, what do we do for the names? Well, we've got y, and y to the third, and then you got the x. There's absolutely nothing wrong with what I just wrote here, but technically, math grammar says our variables should go alphabetically. So technically, this is correct up here, but technically it's more correct to say 420xy to the third. My math lab should accept it either way. If it does not, if you put this in for this and it says it's wrong, let me know and I will change it for you again. So what if we have a number that isn't a single digit? Let's say we have x plus 5. That's a 2-digit algebraic number. And what if I want to multiply that by another number? For example, let's say we have 7 times x plus 5. Well, if we were dealing with whole numbers, let's say we had 3 times 28. We would set it up like this, 28 times 3, and we would do the 3 times 8 and the 3 times 2, correct? We're going to do the exact same thing here. I usually put the number with the most digits on top, that's the x plus 5, times 7. 7 times 5 is 35, so positive 35. 7 times x is 7x. 7x plus 35. Now, some of you might be looking at this here and thinking, we were taught to do something called distributing. Distributing or distribution is nothing more than a shortcut for what I just did here. This is the real way of multiplying that out. But many algebra books take a shortcut where they say when you have a problem like this, you distribute. 7 times x is 7x. 7 times 5 is 35, and it's a positive 35. Notice we get the same answer. Now, for the first few times we do problems like this, I will probably write them out this long way. Then after doing them a few times, I will probably start shortening them up to distribute. But remember, this process here of distributing is nothing more than just a shortcut. If you learn distributing and you're really good at it, do it. You don't have to do it this way. I'm just going to do it this way so that you can get used to where the numbers come from is all. And at some point, if we get to where you guys don't like that and just want to see it distributing because you understand where it comes from, just let me know and I'll stop doing that. No. So here, we have 5 times 4x plus 9. So again, I'm going to write it as 4x plus 9 times 5. 5 times 9 is positive 45. 5 times 4x, 20x. Very good. Any questions? So here, as we said, we can have individual digits, positive or negative on their own with our algebraic numbers. So here we have 3x minus 6 times 7. So this is not 7 times 6. It is 7 times negative 6, which is negative 42. Perfect. Again, the negative goes in front of it just like a minus. Then we have 7 times 3x, which is 21x. Now, for those of you that do like distributing, and I like distributing too because it's quicker. Again, this will just be 7 times 3x is 21x. 7 times negative 6 is negative 42. So we get the same thing. Well, we can change it up just a little bit to have something like this. We can still set this up as a long multiplication. Do I have to slide that 3x over or anything? No, because when I multiply, I do not need the same name. 3x times 2, 6x. It's positive, so I'm going to put a plus in front of it. So plus 6x. 3x times 5x. 15x squared. X times x is x squared. So you can see here when I wrote out our multiplication before with whole numbers using the place values, this follows the exact same process. Or if you wanted to distribute, of course, 3x times 5x is 15x squared. 3x times 2, 6x, and it's positive, so we put a plus in front of it. I'm going to have you guys try this one. What'd you get? Perfect. Anybody getting different? Okay, perfect. What's different here? Oops, you've got this extra thing on the end here, don't we? This is now more than one operation going on. This is technically an order of operations problem. This is pretty much the same as something like this. 2 times 5 minus 3. Where I have to multiply first and then subtract. So over here, I'm going to multiply the 8 times 3x plus 7 first. I'm going to multiply that just like I did before. I could write it out, 3x plus 7 times 8, or I could do distributing. Either way, I'm going to get 24x plus 56. I'm going to pause for a second and make sure everybody gets that. Because I'll get the 24x plus 56. Anybody not see where it comes from? Okay. So then we have to subtract the 8. Where can we subtract the 8 from? 56. That's 8 ones. So 56 minus 8 is 48. It's still a positive 48. This is 24x plus 48. One of the toughest things when dealing with algebra is to stop right here. Because you are done. There's nothing more you can do. But it is so very, very tempting to try to keep combining things. But you have to stop. These are now different names. We cannot go any further. It really is a single number right now with 2 digits. So we might try something like this. And I'm going to give you guys a couple minutes to give that one. Where do we start? We're going to multiply. 3x times 9x is 27x squared. Okay? And then 3x times negative 2 is negative 6x. And then, not divide, but we're going to add the 5x. But now we have a negative 6 plus 5. It gives us negative 1x. So 27x squared minus 1x. Or we don't have to have that 1 in front of it. We could just write it as 27x squared minus x. Any questions on that one? Let's try another one similar to that. Give you guys a chance to do that one quick. Where do I start here? We're going to multiply. Perfect. 5 times the 7x, 35x. And then 5 times negative 3 is negative 15. Perfect. Does everybody understand where that part comes from, or any questions on that part? Okay. Then what? Perfect. We have the 2x that we have to add to 35x. So since they're both x's, those two get combined. So 35x plus 2x is 37x. The negative 15 stays unchanged in that step. Nope, because when we add, we combine counts and we keep the same name. So like up here, when we did the 3x times the 9x, then it became x squared because we were multiplying. Let's look at this one. I'll give you guys a second to give that a shot, and then we'll talk about it. Where do we start? We're going to multiply. Good. Perfect. So we're going to multiply through the parentheses. So we have the 4x times 3x plus 5. So we start out with perfect. 4x times 3x is 12x squared. And then 4x times the 5, which is 20x. Good. Now what? So we have the negative 5x squared, which we're going to take from where? The 12x squared. Good. And you have the 2x, which we're going to combine with 20x. It's a positive 2x, so it's plus 2x. So 12x squared, 20x. 20x plus the 2x is so positive 22, just x. When we add, we keep the same names. And the 12x squared, negative 5x squared, 7x squared. Wonderful.
I thought we were subtracting the 5x squared from 2x, so I did.
Ah, see. You were thinking this.
Yes.
There's no parentheses there. So you're just subtracting the 5x squared and adding the 2x. If there had been those red parentheses there, then you would have been correct. Again, a very subtle difference. Try this one. So this one's a bit more complex. So again, we're starting out with a multiplication. 3 times the 7x minus 4. So 3 times 7x, 21x. 3 times the negative 4, negative 12. And now we are subtracting 2x squared plus 9. Where's the 2x squared go? Yeah, there's no other x squareds. We can think of this as being a 0x squared up here. Where's the 9 going to go? Under the 12, under the minus 12. Now we are still subtracting here. Since this is in parentheses, both of these are being subtracted. So this is negative 12 minus 9. Or negative 12 plus a negative 9, which will be negative 21. How about the 21x? Yeah, basically nothing happens. Think of that as a 0x. It's still 21x. And 0 minus 2 is negative 2x squared. All right. Well, we can keep going just a little bit further with this. We can look at something like this. Talk me through this. We're going to do this multiplication first. So 3x times 2x is 6x squared. Then 3x times negative 4 is negative 12x. Then we have to do this multiplication. 7x times 8x is, it's positive, so I'm going to put a plus, 56x squared. 7x times 1, positive 7x, so just 7x. Now we can go back and combine the 6 and the 56. I could move it over and write it like this as well if I wanted to. But 6 and 56 make 62x squared. They're both positive. Because we're plussing, yep. Negative 12x and positive 7x make negative 5x. This one here has an extra little twist to it. It starts out exactly the same. 5 times the 3x plus 2. Well, what's 5 times 3x? 15x. 5 times positive 2? Positive 10. Now over here, it is not 4 times 5x minus 3. It is negative 4 times 5x minus 3. So negative 4 times 5x is negative 20x. Negative 4 times negative 3 is positive 12. And now I can combine 15 and negative 20x. Negative 5x, yeah. Positive 15, negative 20 is negative 5. And then 10 and 12 make 22, so it's positive, so plus 22. What do you think? Better to sharp stick in the eye? Yeah. That's a quick answer. I'm impressed. Good. At this point in the semester, usually people think about that one for a while. So we can manipulate our variables like that. Now in that form, they're not horribly useful. I mean, we're dealing with formulas and equations. We can manipulate them. And the applications of that in the real world are fairly limited. But there are applications, a lot of applications, where we're going to be given something like this, where some value that we're interested in might be given like that as a formula, where P is equal to 2M plus 7Q. Well, right now there's nothing to do here, but based on information, right now this is just, like we said, is a formula. Those are representing any value that we could put in there for them. But let's say based on current conditions, M is equal to 5 and Q is equal to 3. Now we can do something called evaluate. If you're looking at instructions and trying to figure out what to do, what we were doing up here, where we're just combining the terms and doing the operations with the variables, but still being left with something with a variable in it, that would be called simplify. Combine it as much as you can, but you're not going to be able to get it down to a single numerical answer. Evaluate means you're going to give it a value. You will be able to get it to a single numerical answer. We're going to do what with the M here? Yeah, we're going to replace it with 5 because M equals 5. So this is going to become 2 times 5 because it's 2 times M. Plus 7 times Q becomes 3. 7 times 3. And now this is simply an order of operations problem like we've had before. What do we do first? 2 times 5 is 10. And then 7 times 3 is 21. And we add to get 31. So P is 31. Well, you could write it as P equals 31 if you wanted to. 31 is really what we're looking for there. We might have M is equal to 5D squared plus 4L over 3P minus 2. We're given that. I'm going to give you guys a shot. Try to evaluate that quick, and then we'll look at it in just a minute. So let's take a peek at this. So we're going to start out, this is going to be 5 times 4 squared plus 4 times 6 over 3 times 2 minus 2. Where do we start? Exponents, yeah. This is that fraction bar, of course, is an enclosing symbol, so we have to start on top. And we have an exponent, 4 squared, which is going to be 16. Okay, what do we do next? 5 times 16 is 80. And then 4 times 6 is 24. And then?
3 times 2.
Careful.
6.
We still got to do the 80 plus 24 is 104. Now that we've finished the top, now we can move to the bottom. Down there we do 3 times 2 is 6.
6.
Minus 2 is 4. 104 divided by 4, 26. Any questions on that one? Sure. There?
Yeah. I mean, I get the number and I get how we got there. I just don't know how I got some of my numbers.
Where your numbers came from? A lot of times the hard part is remembering that this is multiply at each of those. Like I said before, I find that a lot of the mistakes are copying the problem down wrong, or once you put the numbers in, rewriting it wrong, and stuff like that. If you look at it closely, you can't figure it out, let me know and I'll help you here when we're done in a couple minutes. So for this one, now let's try to evaluate that. Let's see how you did. So of course we're going to put the numbers in here. This is going to become what? 11 plus 17 times 6, and of course over 2. So what do we do first? 11 plus 17 is 28 times 6, which is 168. Over 2 makes it 84. 168 divided by 2 is 84.
So the A in front of it is nothing.
That's just saying A equals 84. That's and what it might say is evaluate or solve for A or something like that. Those would be the two most common commands for that. Okay. We have 10 minutes left. I'll give you a chance to get started on your stuff if you need to. For those of you here in Rice Lake, the computer lab that's 3 doors down is open and reserved for us. So if you want to go down there and start on the quiz, you can. I have it reserved until 8:20. So if you want to work on there on your quiz for a while, you can. There is a new quiz, quiz 1, as I said, that is due tomorrow, that is Wednesday, by 11:59 p.m. There will also be a new homework. That'd be homework 2. It'll be due on Thursday at the start of class.